Imagine your heart suddenly seizes, breathing stops, your pulse vanishes, and oxygen-rich blood stops flowing to your brain. For centuries, medical science viewed this exact second as an irreversible boundary. Once a patient crossed over, there was no coming back. This sudden, catastrophic shutdown is known as sudden cardiac arrest. According to standard biology, the moment the pumping stops, a rigid timer begins. Deprived of oxygen, brain cells start to die off, locking in permanent destruction within minutes. People often confuse this condition with a heart attack. A heart attack is largely a localized plumbing problem, a physical blockage in a single artery. Cardiac arrest is a catastrophic electrical failure. The heart's internal wiring malfunctions, and the entire organ instantly loses its ability to pump. Blood pressure drops to zero. With no fresh oxygen reaching the skull, consciousness simply blinks out in a matter of seconds. Without immediate medical intervention, the neurological damage locks in. You cannot survive. But researchers have documented a hidden biological window, a gray zone, where the human body actually fights to delay that destruction. As oxygen levels drop, the body's automated survival mechanisms kick in. It constricts blood vessels in the arms and legs, forcefully redirecting whatever trace amounts of oxygen are left straight to the vital organs. In rare situations, this window stretches. A woman in Norway once fell into freezing water and went into cardiac arrest. Her heart remained stopped for over an hour, yet she fully recovered. This line graph illustrates how she survived. At normal body temperature, cellular decay happens rapidly, but under extreme cold, a medical state called therapeutic hypothermia, metabolism slows to a crawl, drastically flattening the curve and delaying cellular breakdown. Her extreme exposure proved that the brain can tolerate oxygen deprivation far longer than medical textbooks claimed. The biological process of death can actually be paused. Today, modern hospitals deliberately push patients into this extended gray zone to pull them back from the edge. They rely on machines like this one, ECMO, or extracorporeal membrane oxygenation. It effectively acts as an artificial heart and lungs outside the patient's body, pumping fully oxygenated blood through their veins. By bypassing the heart and taking over circulation entirely, ECMO buys surgeons several hours to find and fix whatever caused the cardiac arrest in the first place, while the patient remains functionally dead. Suspended in this state, some survivors return with vivid memories. They describe moving through tunnels, seeing bright lights, or watching doctors work from somewhere above their own bodies. While these accounts inspire mystical interpretations, scientists point to biology. They theorize these visions are the result of abnormal electrical signals firing rapidly across the brain as it fights through severe oxygen starvation. By combining precise temperature control and mechanical circulation, medicine has successfully stretched our biological limits, revealing clinical death as a suspended state of extreme emergency. But there is, however, a brutal catch. An ECMO machine and therapeutic hypothermia are entirely useless if the brain's own cells decay before the ambulance even arrives. Bystander CPR operates as a strict biological requirement. It functions as a manual mechanical pump, physically forcing a trickle of blood upward to keep the brain intact. At the same time, devices like defibrillators are needed to forcefully shock the heart's chaotic electrical grid back into a normal, organized rhythm. Without those initial chest compressions, the timer runs out. They are the only way ordinary people can manually hit pause on the dying process. Medical science has dismantled the centuries-old belief that your life ends in one irreversible instant. Clinical death is a fragile, incredibly narrow window where a dying person hovers right on the edge of permanent loss. Advanced hospital machines and freezing temperatures can pull someone back from that edge, but they are only half the equation. In those critical first minutes, the difference between permanent biology and a second chance at life is entirely dependent on whether someone nearby is willing to step in and push.